Hey guys, today we're going to learn about the remainder and factor theorem. Now, in order to apply these theorems, we need to learn about something called synthetic division. In our previous lesson, we learned how to divide polynomials using long division. Synthetic division is another method of dividing polynomials, but only if we are dividing by what's called a linear factor. So let's take a look at this example. We have 6x to the third minus 25x squared plus 18x plus 9, and we're going to divide that by x minus 3. This is a linear factor, and how you know it's linear is because the exponent of x is 1. If the exponent of x was anything other than 1, then you would not be able to use synthetic division. Now how this works is first you take the factor that you are dividing by and you make it equal to 0 to solve for x. We get that x is equal to 3. So here you're going to open up a little box and you're going to put 3 inside that box. Now you're going to get your coefficients from the polynomial and you're going to write them all along here in a row. So 6, negative 25, 18, and 9. So that's step 1. Write the coefficients of the dividend in standard form and write c of the divisor, x minus c, in the left-hand upper box. And now we're going to draw a line here and we are going to bring down the first coefficient. So this is how you set up. Now what we do here, it's a pattern. You're going to take whatever number is in the bottom and multiply it by the number in the box. 6 times 3 is 18. So that is step 2. And we write it here. Next, we add the product and the second coefficient. So we add these together. Negative 25 plus 18 is negative 7. Now we repeat steps 2 and 3 until you reach a sum in the last column. So now I'm going to repeat. Negative 7 times 3 is negative 21. 18 minus 21 is negative 3. Repeat. Negative 3 times 3 is negative 9, and 9 minus 9 is 0. This last number, this is the remainder. Since the remainder is 0, that means that this is a factor of my polynomial. So now, what do these numbers here represent? Which I wrote here. The numbers along the bottom row are the coefficients of the quotient. The power of the first term is 1 degree less than the degree of the dividend, and the final number is the remainder. So how we write our answer, this is our quotient. Since our original polynomial was x to the third, right, it was a third degree polynomial, then that means that our answer, since I divided by a linear factor, meaning I take degree, I am going to start with 6, that's my coefficient, x squared. So it's 1 degree less. And now we go down in order. So then this would be x and this would be the constant. So minus 7x minus 3. This is my answer. This is called a depressed polynomial. It's called depressed because I took away a degree and so the degree lessened. So it got smaller. That's what they mean by depressed. And it goes to show, it goes without saying that this is also the quotient, your answer to the division. Let's try with a couple other examples. Divide using synthetic division. Express your answer as a depressed polynomial. When a polynomial is divided by a factor, the quotient is called a depressed polynomial, which is what I said. And just as with long division, remember to use zeros as placeholders for any missing terms in the dividend. So let's look at this one here. First, I need to figure out what's going to go in the box. We take our factor here, the x plus 1, we make it equal to 0. And we would get here that if I subtract the 1, x is equal to negative 1. So that's what I'm going to put here. Now we write our coefficients in order going across. So we're starting with 3. Now notice that this is x to the third and then it jumps to x, meaning that we're missing the x squared term. So I'm going to put 0 where x squared would go, then 2, then negative 1. Bring down the first term. Now we start our pattern. Multiply, add, multiply, add. So 3 times negative 1 is negative 3. 0 minus 3 is negative 3. Negative 3 times negative 1 is 3. 2 plus 3 is 5. 5 times negative 1 is negative 5. And here we actually get a remainder of negative 6. So now we're going to write out our answer. Since our original function here was to the third, that means that this is going to start to the second. So this is going to be 3x squared. And now we go down in order. Minus 3x plus 5. Since this is my remainder, in this case, subtract since it is negative. And we put the remainder over what we divided by, just like we do in long division. So x plus 1. This would be my answer. Let's try one more. Here we have 6x to the fourth plus 11x to the third minus 15x squared minus 12x plus 7 divided by 3x plus 1. So first I'm going to figure out what's going to go in the box, making 3x plus 1 equal to 0. Subtract the 1, we get 3x is equal to negative 1. And then divide the 3, x is equal to negative 1 over 3. So that's what's going to go in the box here. We're going to write our coefficients. I'm not missing any terms, so we can just write them all as we see them. 6, 11, negative 15, negative 12, and 7. Bring down the first term. Now I know what you're thinking, we have a fraction here. When we're multiplying any number by a fraction is basically division. So instead of thinking of 6 times negative 1/3, you can also think of this as 6 divided by negative 3. Since multiplying negative 1/3 is the same thing as dividing by negative 3. So let's do that. 6 divided by negative 3 is negative 2. 11 minus 2 is 9. 9 times negative 1/3 is the same as 9 divided by negative 3, which is negative 3. Negative 15 minus 3 is negative 18. Negative 18 divided by negative 3 is 6. Negative 12 plus 6 is negative 6. Negative 6 divided by negative 3 is 2. And 7 plus 2 is 9. This is my remainder. Since my original polynomial was to the fourth, that means that my answer is one less third. So this starts with 6x to the third plus 9x squared minus 18x minus 6. Then I'm going to add my remainder, so plus 9. And I'm going to put that 9 over what I divided by, which is the 3x plus 1. As soon as this lets me write. There. This is my answer. So that's synthetic division. Now let's look at what is the remainder theorem. Before I explain what the remainder theorem is, let's have a look at this example. If I have f of x is equal to x to the third minus 4x squared plus 5x plus 3, I'm going to find the value of f of 2 using regular substitution. And what I mean by that is when we see f of 2, what that means is that we are going to plug in 2 into every x. So this is going to be 2 to the third minus 4 times 2 squared plus 5 times 2 plus 3. Oops. 2 to the third is 8 minus 2 squared is 4 times 4 is 16, plus 5 times 2, which is 10, plus 3. 8 minus 16 is negative 8, plus 10 is 2, plus 3, we get 5. Now let's see what happens if I use what's called synthetic substitution. What that means is if I'm trying to evaluate f of 2, you know how we always get our factor that we're dividing by and we put it in the box? Well, this number is what I'm going to put in the box. And I'm going to see what happens when I divide this polynomial by that particular number. So I'm going to write my coefficients here in order like I always do. So 1, negative 4, 5, and 3. Notice we're not missing any terms, so I didn't have to worry about putting any zeros. Bring down the 1. 1 times 2 is 2. Negative 4 plus 2 is negative 2. Negative 2 times 2 is negative 4. 5 minus 4 is 1. 1 times 2 is 2. And 3 plus 2 is 5. So what the remainder theorem tells me is that whatever you get for the remainder is the same value that you're going to get if you use regular substitution. So it's another way, sometimes faster, than just plugging in the number and evaluating. So let's try that. Use the remainder theorem to solve for the indicated function value. So for the first one, f of x is equal to 3x to the third plus 4x squared minus 5x plus 3, and we want to find f of negative 4. So that means that in the box, I'm going to put negative 4, and going across, I'm going to put these coefficients. So 3, 4, negative 5, and 3. Again, I'm not missing any terms, so I don't need to worry about that. Bring down the 3. 3 times negative 4 is negative 12. 4 minus 12 is negative 8. Negative 8 times negative 4 is 32. Negative 5 plus 32 is 27. 27 times negative 4 is negative 108. And 3 minus 108 is negative 105. So since this is my remainder, that is my function value. So f of negative 4 is equal to negative 105. And this would probably have been easier than if just taking the negative 4 and plugging it directly into the function. Let's look at a word problem. The number of tickets sold during a high school's football season can be represented by t of x is equal to x to the third minus 12x squared plus 48x plus 74, where x is the number of games played. Use the remainder theorem to find the number of tickets sold during the 12th game of the season. So what I'm trying to find is t of 12. So I'm going to put 12 in my box, and I'm going to write the coefficients going across. So 1, negative 12, 48, and 74. Bring down the 1. 1 times 12, 12. Negative 12 plus 12, 0. 0 times 12, 0. 48 plus 0 is 48. 48 times 12 is 576. And 576 plus 74 is 650. So this means that 650 tickets were sold during the 12th game. Now, moving along, we're going to go into our factor theorem, which is actually an extension of the remainder theorem. Now, the factor theorem is basically saying that if I go through my synthetic division, and if I get 0 as a remainder, then that means that that particular factor that I divided by is a factor of the polynomial, and you can use that to write your polynomial in factored form. If we get a remainder that is not 0, then that means that that particular factor is not a factor of the polynomial, and you cannot use it to completely factor. So sometimes it's a lot of factors, but so let's have a look at this particular example. Determine if the binomials are given factors of f of x. Use the binomials that are factors to write a factored form of f of x. Then state the roots of the function. So you're doing two things here. You're finding the factored version of the polynomial, and you're finding the roots, which, remember that roots is just another word for the zeros or the x-intercepts of your polynomial. So let's start with x plus 3. We're going to check if this is a factor. So I'm going to put -3 in my box, since that is what makes this factor equal to 0. And I'm going to put my coefficients here in a row. So 1, 2, -1, -2. Bring down the 1. 1 times -3 is -3. 2 minus 3, -1. -1 times -3 is 3. -1 plus 3 is 2. 2 times -3 is -6. And -2 minus 6 is -8. Since we got a remainder that is not 0, that means that x plus 3 is not a factor. So now let's check x plus 2. That would mean that -2 would go in the box, since that is what makes this equal to 0. Writing our coefficients again, we have 1, 2, -1, and -2. Bring down the 1. 1 times -2 is -2. 2 minus 2, 0. 0 times -2 is 0. -1 plus 0 is -1. -1 times -2 is 2, and -2 plus 2 is 0. Since we end up with 0 as a remainder, that means that x plus 2 is a factor of my polynomial. So let's write this polynomial in factored form so far. We have the original factor that I divided by, which is the x plus 2. Then we have our answer here. Since the polynomial was to the third, that means that this starts with x squared. So 1x squared is just x squared. We have 0x. We don't write the 0x. And then we have the -1. This is a difference of squares. So I can continue to factor this. This means that f of x is going to equal to x plus 2, and x squared minus 1 is x plus 1, x minus 1. Since to factor a difference of squares, you square root the first term, which is x, square root the second term, the square root of 1 is 1, make one factor plus, make one factor minus. This is my polynomial in factored form. You must include the original factor that you divided by, or else it is not your polynomial. Think about it. If your exponent is 3, that means you should have 3 factors. Now for the roots. The roots are what make the polynomial equal to 0, meaning x plus 2 must equal to 0, x plus 1 must equal to 0, and x minus 1 equals to 0. And now we solve. Here we get that x is equal to -2, since I would have to subtract the 2. Here, -1, since I'd have to subtract the 1. And here, +1, since I'd have to add the 1. These are my roots. Let's try another one. Given the equation and 0 below, find the remaining factors of the polynomial to write the polynomial in completely factored form. Then state all of its roots. So here, instead of giving you a factor, you are given the actual 0. This is already once the factor is equal to 0. So this number you're going to write in the box. This would be the factor x minus 3. Since in order to make this equal to 0, I have to subtract the 3. So this is what we would have seen. If it was this divided by x minus 3, this is our 0. Now we're going to write our coefficients. We're not missing any terms, so 2, negative 3, negative 11, and 6. Bring down the 2. 2 times 3 is 6. Negative 3 plus 6 is 3. 3 times 3 is 9. Negative 11 plus 9 is negative 2. Negative 2 times 3 is negative 6. And 6 minus 6 is 0. So since it is a factor, that means that I can write my polynomial in factor form. So let's write that out so far. We have the original factor that I divided by, which is the x minus 3. See, this is, if you didn't rewrite your root as a factor, you would need to do so now to put your polynomial in factor form. Now, these numbers here. Since my polynomial was to the third, that means that this answer here, my depressed polynomial, would be to the second. So this would be 2x squared plus 3x minus 2. To factor this particular quadratic, you can do so in two ways. You can either use the AC method, which is the way that I'm going to use, or if you don't remember how to use the AC method, you can always use the quadratic formula to give you the roots, and then use those roots to put it back into its factored form, like how I did here. But let's practice using the AC method. So I'm focusing in on this. AC is when I multiply the 2 times the negative 2, because this is, remember, this is A, this is B, this is C. So AC is negative 4. Then the two numbers that multiply to give me negative 4, but add to give me B, which is positive 3, would be 4 and negative 1. I'm going to rewrite this using my new numbers for B. So 2x squared plus 4x minus x, that's the 4 and the minus 1 right here. And I have x attached because this is B, and B always has x. And then the minus 2. Since I have 4 terms, we're going to factor by grouping. These first two both have a 2 and an x in common, leaving me with x plus 2. These two here both have a negative in common, so I'm going to factor out a negative 1, and that would leave me with x plus 2. So my factors here are going to be, let's write our whole polynomial. We got the x minus 3 from the beginning. From here, they both have the x plus 2, so I'm taking out the x plus 2. And then what's left over is the 2x and the minus 1. This is my polynomial in factored form. Now for the roots. We're going to set each individual factor equal to 0. Solve for each x. Here I'd have to add the 3, so x is equal to 3. Here I'd have to subtract the 2, so x is equal to negative 2. And this one is a two-step, so I'd have to add the 1, so 2x is equal to 1, and then divide the 2. So x is also equal to 1/2. And this would be my roots of the polynomial. Let's try another one. We have here 15x to the third plus 14x squared minus 3x minus 2, and I want you to see if x plus 1 is a factor of the polynomial, and if so, you're going to find the remaining factors of the polynomial to write it in factored form, and finally state all of the roots. So here you're given the factor, so we're going to make that equal to 0. So this means that x is equal to negative 1. This is what I'm going to put into my box. So the difference is that here you have that x does not equal to anything, so we have to make it equal to 0 and solve. Versus here, we get that x equals to 3, so we didn't have to solve, you just had to put that number in the box. So that's the difference of how you can see these questions. Now let's write our coefficients: 15, 14, -3, and -2. Bring down the 15. 15 times -1 is -15. 14 minus 15 is -1. -1 times -1 is 1. -3 plus 1 is -2. -2 times -1 is 2. And we get here a remainder of 0. So x plus 1 is a factor of my polynomial. So let's write our polynomial so far. We have the original factor, which was the x plus 1. Then we have this, our answer. Since our original polynomial was to the third, that means that this one is going to start with x squared. So 15x squared minus x minus 2. Now here I have my quadratic, but since I have a number in the front that I could not divide out, that means that I'm going to have to use the AC method. So AC is 15 times -2, which is -30. And the two numbers that multiply to give me -30, but add to give me -1, are -6 and 5. So let's write this using our two new values: 15x squared minus 6x plus 5x minus 2. Now we factor by grouping. 15x squared minus 6x, both of these numbers here can be divided by 3, and they both have an x in common. So that leaves me with 5x minus 2. For the second group here, we have nothing in common. And if they have nothing in common, you're just going to put a plus, whatever the sign is, 1, and copy it down. Since remember, we know if we've done this right, if what's inside of these parentheses are identical. Now we're ready to write our polynomial in completely factored form. We have the x plus 1. Then we have the 5x minus 2, the ones that are identical. And what's left over on the outside is my other factor, so 3x plus 1. This is my polynomial. Now to get our roots. We're going to set each of those factors equal to 0. Here we get that x is equal to -1. Here I have to add the 2 first, so 5x equals 2, and then divide the 5. So x is also equal to 2 over 5. Then here I'd have to subtract the 1, so 3x equals -1, and then divide the 3. So x is also equal to -1 over 3. So these are my roots. So we have our factored version and we have the roots. So make sure that whenever you're given a question, look at what's being asked. Are you being asked to write the polynomial in factored form? Or are you being asked to state all the roots? Or are you being asked for both? So make sure that you always look back at the instructions so you know how to answer your question. And that is the remainder and factor theorem.